Hello! In this video I'm gonna give brief introduction what Kaamos Tech are doing and what kind of content you can expect from upcoming videos. Here I have some of the Kaamos Tech boards so I can show some examples what we're doing. One of our most popular boards is the ADC. This is ADC AK5572 and the name just comes after the main ADC chip. You can get this board with balanced XLR inputs or unbalanced RCA inputs. It has I2S output, or you can also use DSD output. All the outputs are with UFL connectors for good signal integrity and clock quality. Here's an external power supply connector, or you can just solder your own wires. This connector is to be used with our own power supplies. The performance of this board is excellent and you can find the details on our website. This is the W-Duck. This is kind of where everything started from for me, the first or early revision of this one. It's based on AKM AK4493 duck. It comes with single-ended outputs, but you can also get a balanced add-on. It's a very compact form factor. That was one of the points to design this board. To build a complete duck, you also need SPDIF receiver. So this DAR18 is an SPDIF to I2S port. It takes in coaxial or optical SPDIF, or you can get add-on for balanced AES input, or you can wire the XLR just here on board. Like the duck, this is available in hardware controlled mode where you just select inputs with jumper links, or this one is actually I2C version if you want to use microcontroller to control your boards. This is the opposite to the previously shown DAR18, so this is SPDIF TX board and it is from I2S to SPDIF, so you get SPDIF output. And this is usually used, for example, with DSPs. If you have DSP ports with I2S output and you want to convert it to SPDIF, you need something like this. And it has a full range of output, so you get all XLR, BNC, or you can get RCA from the BNC with just a simple adapter and an optical output as well. This is a clock buffer, the clock buffer 1 to 3 port. Often when you connect converters like ADCs and DACs to a DSP, for example, you need to split the clock signals because you may only have one of each clock outputs, and if you have a multi-channel board, you want to connect many ADCs and DACs. So then you need to split the clocks, and the proper way to do it is to use dedicated clock buffers. And that's where this board comes in. You take the clocks in the pin headers or the UFLs, and each of these 4 inputs has 3 duplicated outputs. It's a simple board, but it serves an important task. This is our first power supply, one for all, something I've wanted to make for years. So you have a single USB-C input, you can use power bank or USB charger, and you get all the output voltages that are required by our ADCs or DACs, or the digital boards just use this small connector. So you get plus minus 14 volts used by op-amps for input and output stages. Then you have 5 volts for digital and 6 volts for analog references. It depends on the current consumption of the boards, but you can typically power multiple boards with this one power supply. And this was just a brief overview of the products we have at the moment. I will go in more detail on each of these boards in upcoming videos, and of course there will be more products coming in the near future. Another part of the content is hi-fi and hi-fi products. Not to review products for the sake of content, but to record my personal hi-fi journey. This is when I buy or try new products for my own use. Recently I also did a bit of speaker DIY by giving my old cinema speakers a facelift and building 2 new subwoofer boxes. So if you're interested, please check the upcoming videos.